My name's Dick Dunn. I'm with Michael Baker, and we are one of the contractors working with Federal Highway on the long-term bridge performance program. So when we were putting together the agenda, it suggested that it might be a good time to figure out if we could give you a little update on what's happening with the long-term bridge performance program. And it was on the earlier version of the agenda, and then the last version, it disappeared. And they said, well, wait a minute, we need to still shoehorn you in there. So I talked to the folks at Federal Highway, and they said, yeah, go give the presentation. And they sent me 50 slides for a 15-minute presentation. So I've tried to whittle them down, but I didn't quite get as far down as I would have liked. But I am from New Jersey. That's a good point, so I will talk fast. So we should be in good shape. So first of all, this is the team at FHWA at Turner Fairbanks, headed by Dr. Hamid Qassemi. Rob Zobel is the program manager, and then they have a bunch of folks that are part of it, as well as some temporary rotational staff that you see down there, folks that rotate in and out of the Turner Fairbanks office, and they're all helping move this long-term bridge performance program along. So what we want to talk about today is some of the products that they've put together already, what's being done on the data collection, kind of a status update, and then kind of where the vision is going forward. So first of all, the products that have been developed to date include the protocols, which are basically the way they're going to collect data, the way they're going to store data, and the way we're going to test the sampling that we do out on the concrete decks and other pieces of the bridges that we're testing. There's a bridge portal that is, they tell me it's operational, but I know some states are still having problems getting in, and I would just suggest that you get in touch with Rob Zobel, who is heading up the project to get you that access that you need. They're developing a deterioration and forecasting model based on the data that's been collected to date. They're developing a bridge performance index, bridge practice timelines. I wouldn't go into these as we get along here. So the LTB protocols that they've developed so far, they've got over 100 protocols right now. It's really for the consistency of the data that you're collecting. This is research quality data, so it's going to be a little bit more in-depth than you would collect in your normal NBIS inspections. So there's also a bunch more protocols that have been drafted and are ongoing review, and so it's all coming through. Now, if you as a state would like to utilize these protocols when you're doing your bridge inspection, you know, you feel free to have at it, and you'll be collecting data that will be able to be put into the portal because you're using this methodology to collect your data, although it is much more time consuming than your normal NBIS data collection. So the bridge portal basically is a tool that's going to collect all the data and allow them to do the deterioration modeling, the statistical analysis, you know, a life cycle modeling and visualization and mapping of where these bridges are that are in these conditions. And it collects all the information, you know, that you need that affect a bridge's performance. You know, your traffic data, your weather data, you know, what type of maintenance and preservation has been done on bridges, those sorts of things are all collected and put into the portal, and they use that to develop some models and making some decisions. So this is kind of the envision of what the portal is going to look like. So you have the various data sources that you collect to that impact your bridge's performance. Then they're going to use these tools that you can use to identify your bridges, and then there's future development of different things that they're looking to do, advancing the deterioration model, having some apps that would be readily available to the owners and users out there. And the stuff that's highlighted in yellow is the stuff that's actually been completed, so that if you were successful in accessing the portal, you'd be able to look at these things. And this is what Rutgers is doing that work. They developed the portal. They are the ones been charged with by FHWA and the Long-Term Bridge Performance Program to develop that. They had at TRB this year, they had a half-a-day session on Thursday, the last day there, where they actually walked you through the portal. So they can do it, so I'm assuming that if we could get access to it, that we could do it as well. So they've done this theoretical model. They've validated the model with the field data that they had, and they just need to, make it more robust as they bring in the other data that they're talking about. So, which, there's stuff in New Jersey, New York, and New Hampshire that's being done right now, and then there's the stuff that we've done in the Gulf, as well as stuff that PB is doing out here in the West. So one of the things that you heard Carlos talk about when he gave his opening remarks was he talked about how, there's got to be a plan for each bridge. And if you've heard some folks, and I think Mike Johnson talked about it a little bit, how actually each bridge is going to be different based on the climate, the truck traffic, when it was built, what were the materials used. And so one of the things that they recognized with the Long-Term Bridge Performance Program is there's different timelines of changes made in the way that we as bridge practitioners have designed and constructed bridges. So one of the things that they've done is they have developed and published a tech brief basically noting the changes in reinforcing bars. So that when you are trying to compare the performance of a bridge that was built in the 50s with a bridge that was built in the 70s, the reinforcing steel was different. And how does that impact your bridge's performance? So they're also looking at developing, and they're in the process of developing the timelines for the bridge materials and as well as, from a federal perspective as well as from a state perspective. So they're looking to collect all that data. And that's actually being done by the folks at Turner Fairbanks themselves, some of the folks that were in that opening box that I talked about. So, this is a sample of what they're looking at trying to collect is, some of the states were using latex modified concrete, and now some of them are using the polyester polymer concrete. Why did they make the change? What are the differences that you're seeing in terms of performance based on product X versus product Y? And how does that all play into when you're looking at the national performance of bridges nationwide? National bridges nationwide. I think that's a redundancy there. But, that's how I am. So, how are they collecting the data? How do they propose to collect the data? So they've sorted the country into both clusters and corridors. I tried to get them to change the name from clusters because there's another word that usually follows cluster that my mom wouldn't let me repeat, and I just don't like having it there, but that's the way it's broken out. And really the clusters are based on weather patterns, basically in terms of where you would see commonality in the weather in your bridge population. And then the corridors, as you can see, is basically some of your high volume corridors that you're going to see. You'd want to see how those corridors are performing across the country. So right now, what they've done is we've done a few of the clusters. We haven't done any of the corridors yet. That's to be coming out in the fall. There was supposed to be out in the spring, but it's been pushed off to the fall. It looks like a proposal to gather about 800, somewhere to the order of 800 bridges in the corridors and clusters as a next step for the long-term bridge performance project. So the data collection strategy is data mining, visual inspection, some NDE with the visual inspection. There's the robot-assisted bridge inspection technology, that's the Rabbit as they call it, as well as some modal testing proposed. So I'll go into each one of these a little bit. The legacy data mining, this again goes back to what do states have, what do they have about the distribution of bridge characteristics among and between the bridge clusters, the corridors, what are the parameters that are used to identify bridges that will be used to use as representative bridges for this type of bridge, whether it be a steel girder, concrete deck, concrete girder, concrete deck, or those types of bridges, as well as how do those parameters affect your bridge performance. So what's being done to date is there were 4 indefinite delivery, indefinite quantity IDIQ contracts awarded by FHWA on the long-term bridge performance program. And the firms that got the work were PSI, Michael Baker, PB, and Pannone and Associates. And the legacy data mining is being done by actually Rutgers as part of, they ran the original part of the long-term bridge performance program, as well as the folks at PSI. And so you can see they've got about 400 bridges that they've done the data mining for, that they're incorporating into the portal, and they need to collect about 500 more bridges to continue to do the statistical analysis that they'd like to do. So here are the contractors that are doing the work. Rutgers has already done 2 cycles of inspections in that Mid-Atlantic corridor, and they are using the Rabbit in their bridge inspections. Michael Baker, we completed our first cycle of inspections for the Gulf Coast, and it's steel and pre-stressed concrete bridges in Alabama, Arkansas, Florida, Louisiana, Mississippi, and Texas. PSI are the folks that were just doing the data collection, in terms of just doing the paper studies to come up with that data. And PB is the ones that are working out here in Arizona, California, Nevada, Oregon, and Washington. And they are done with their inspections in Arizona. I believe the plan is to do the inspections in California and Nevada in May, Oregon in June, and Washington in July. And Pannone is doing, they weren't doing any of the data collection, but they were kind of like an on-call consultant helping the folks at Turner Fairbanks with a variety of aspects of the project and the program. So again, here's kind of the overview of what everybody was doing. This kind of goes into a little bit of what Pannone was doing. They're doing a weigh in motion project with Oregon. They're working with the folks from Federal Highway on the long-term bridge performance index. They're doing the website, the newsletter. They're doing all that kind of behind-the-scenes stuff that are helping FHWA and Turner Fairbanks, while the others of us are actually, doing the data collection out there. So this is the breakdown that we did in the Gulf Coast, and it's basically a couple, 2, 4, bridges in each state. If it was a cluster bridge, we only did chloride sampling in terms of testing. If it was a reference bridge, we did 2 types of chloride testing, chloride penetration, chloride profile, 2 different types of modules of elasticity, as well as a compressive strength test. So we're complete with that, and we are also having a little trouble inputting our data into the portal, so we're not quite done with that, even though we're done with our field work. So that's essentially what we're doing. And the way the program came out, I know when I was dealing with the folks in the Gulf, they wanted to know when the Rabbit was going to come to their state, because it's been very heavily promoted. And unfortunately, because there was only the one Rabbit built at the time, it was oversubscribed, so it wasn't able to come down into these states. But the FHWA is in the process of building 4 more Rabbits, so that they will be available to, as I mentioned, there's the ongoing future collection of about 800 bridges data, and they're going to use that. Those Rabbits will be available to those contractors that do that work. Again, this is the work that PB is doing, and like I said, their collection is ongoing, and they hope to have it done by the end of the summer. They had some problems. One of the issues that we both ran into, both PB and Baker, were the bridges that were selected originally from just a paper study perspective. They just didn't work. I know one of the bridges in Nevada that they had over 100,000 vehicles per day, and there's no way they're going to be able to close a lane and do some work, and it was just, that was just not going to happen. So they had to go back and come up with a new list of bridges. You know, and Pannone is doing these various things. I think I have another slide that talks about one of their main projects is the Way in Motion pooled fund study that I think they're working on. So I'll get to that in a minute. This was the focus of the first part of this effort, was the untreated decks, bearings, joints for untreated decks for steel multi-girder and concrete girders. So in fact, that's what we were out there looking at. We and Rutgers looked at steel multi-girders, concrete, pre-stressed concrete multi-girders, and PB's working on the pre-stressed concrete boxes out here in the West. The next effort that's going to go on will be really a continuation of this, but they are going to pick up steel coatings as well as I think the next phase is also going to include the treated timber decks. This is kind of the timeline that they're looking at trying to get all this work done. So it is a long-term bridge performance program, and the focus has been on providing products while also focusing on the long term. And you know, there's a lot of there's a desire from the bridge community to see more from this program. But the reality is, until they collect the data and they're able to analyze the data, the products that you're going to see are just going to be the little bits and pieces along the way, like the rabbit, like the some of the early versions of the deterioration model. You'll see some of that, but it'll all get refined over the years, and it will be similar to the long-term pavement program, which is what it started out trying to mimic. And if you know anything about that program, it took over 20 years before they got any data, usable data, back to the states. You know, the folks at FHWA are very cognizant that we live in a different society now, and they want to, you know, they want to provide products for people that they can use along the way, and that's what they're trying to garner. So this is kind of the look going forward. So what you're seeing here is the bottom rung of those bridges is what we're working on right now, is the set one. Like I said, Rutgers has done actually 2 sets of the Mid-Atlantic region, and the next phase will be, there'll be a second phase of the Gulf, but there'll also be a first phase of, say, the Ohio Valley, you know, going back to that, or there'll be a first phase of the mountain region, which would be right here in Utah, and I think it'd be Denver or Colorado, a couple other states in the mountain area, Idaho. So whatever makes up that cluster would be getting in on the first round in the next go-round. And each time you build this up until you get to a data set that you are sufficient that you can predict performance. So there'll be an evaluation as we move along. So just a little bit of what the way that the program works is the long-term bridge performance program at FHWA is guided by a TRB Bridge Committee Expert Task Group, which they report on. They just had their meetings last week, and they've approved this draft business plan, the strategic roadmap, the pooled fund study of the impact of the live load on bridge performance. That's what Pannone is working with Oregon on, coming up with basically putting a way in motion at a bridge so you're able to collect the data, and it's on actually I think it's on a road that has a lot of logging trucks on it. I'm not sure if I'm saying that right, but I do believe there's heavy truck traffic on it. So they want to be able to measure that, the impacts that trucks are having on bridge performance. And then this is the Virginia pilot bridge, which was taken out of service. And what they're going to do is they're going to actually take parts of this bridge and bring it to Turner Fairbanks and actually test it kind of forensically. To determine, you know, just how much life was actually left. I think this is really a good case point that can be made, what we heard Mike Johnson talking about, like, you know, this bridge is coming out of service, but it's not because it's in really bad condition. It's really bad. It's due to the volume that it needs to serve. It's going to be widened. And so that's what they're doing. So I think this will be a good case study. This is the pool fund study that I mentioned that Pannone's working on with Oregon. These are the other states that are in it, Minnesota, North Carolina, Pennsylvania. Anybody else think PN is not really this word for Pennsylvania? But, I don't know. So, but I don't know, in our program today, we had Chris Keegan from WS, presenting. So, just wondering. So this is really to really make the case of what the trucks, when you get a truck, what is that load? And they're instrumenting all along the beam so you can watch the truck move along the girders and understand what that influence really is. So that's an ongoing project that I think is going to get underway this summer. It's looking at the fundamental questions of, what are the current truckloads? What are the impacts on our bridges? And once we can understand that, then I think we'll be in a better position as Congress pushes to increase truckloads. What are those impacts? What would we see? But if you don't know what the impacts are now, it's really difficult to say, oh, well, we think that there'll be this later. It's a lot of, seat of the pants engineering, if you will, in terms of not really knowing. So that's it. I think I went through that fairly quickly. I will take a few questions. I can't say I'll know all the answers, but hopefully I can. So.
Can you comment at all on the functionality of the website? The last time I tried to log in, I'm the state coordinator for Utah, I could not get in. I requested access, they sent me an access, that did not work. Then I think I did a couple more hoop jumping exercises and still could not get in.
Josh, unfortunately, I don't know that is not a common problem. I think others have had that same problem. I know we've been having problems just updating our data into the portal, and we have access, and we've run into that. So I think so one of the things is the Federal Highway, and I don't know if Raj is here or not, but I know that one of the things that Federal Highway has is their firewall system is significantly different than anybody else's firewall states that I know of, because the way that to get in there to be able to get a hold of that information is very, very difficult. So I think it might be something there, because part of this is, okay, the portal's being developed by folks at Rutgers University, and they're working with the folks, at Federal Highway and Turner Fairbanks, and I think that there might be some issues going on there. But I will bring that back, Josh. I certainly will. Thank you for that.
Dick, you were talking about that they're going to use this study to see if they could increase the truck loading on these bridges. No.
Okay. They're seeing what the impact of today's truckloads are on this one bridge, and then be able to hopefully say that bridge is representative. That's why it's taken a while for them to get to this position, is because they had to find a bridge that was representative of enough of a cross-section so they could say, this is the impact of today's trucks, okay? And they're gonna have a weigh-in motion that's right there with a video camera attached to it, so that when this truck goes across the bridge, not only will they capture the axle loads and axle spacings, but they'll also have a videotape of it, so they'll know, all right, this is what the bridge this is what the truck looks like, so that they can really identify these are the impacts of these trucks and these loads today, so that as Congress and the trucking lobby and everybody really, because the less trucks we have on the road is better for all of us. So if they can increase the weight, that might be better for all of us. But there are issues about braking and loads and things like that. So we're trying to determine that, Siva.
So this particular bridge is representative of that, and that was designed before these trucks were in operation. So that design capacity was lower than this truck loading.
Oh, absolutely, absolutely. It's just similar to many of the, I think it was in Mike's presentation today showed you this is what stuff was designed for, and this is what it's seeing. So we're actually trying to capture that. So.
Anyone else? Okay.
All right, so now I was sufficiently short, the business needs to be sufficiently short.